talk about scientific notation. Okay? Are you guys familiar with scientific notation at all?
Sort of.
Sort of? What is scientific notation and what's the purpose of it?
To shorten a really big number.
Exactly. It's for scientists and other people who are you talking about either scientific terms or math terms to shorten real big numbers into smaller numbers, kind of like an abbreviation, like a contraction. If you have the word aren't, or you have the word are not, and the word aren't is kind of shortened of it, shortened version of it. When we do scientific notation, there are two main key players in it. One of them is the number, okay? The second one is the number 10 followed by an exponent. Now, you base what the number is based on the number that's given to you, okay? You base the exponent on how many times that you have to move the decimal. So let's say we have, I'm going to show you guys how to do it both ways. Say we have the number 9,000, and we want to write that in scientific notation. Remember what I told you guys about decimals? If you don't see a decimal in the number 9,000, there is an invisible decimal at the end of it, okay? The first thing that you want to do is, you want to get this decimal till you get to the very front of the first number. You want it to be in front of the first number. So, the first thing I'm going to do is I'm going to put the number 9. And when I say the first number, I mean the first whole number, the number 9. However many times I move this decimal, that's 1, 2, 3, 4. That's going to be my exponent. So 9,000 in scientific notation would be 9 times 10 to the third power. Another way to write this is 9 and 10 to the third power, meaning that I add 1, 2, 3 zeros, and I get 9,000. Now, in order to work these, you would have to understand this pattern. But let's talk about the logical mindset of it. Why do we just add zeros when we're talking about 10 to the third power? Because when we're talking about exponents, 10 times 10 would be 10 to the second power, wouldn't it?
Yeah.
And in order to write that, you would just write 10, this number, and then add this 0, and you would get 100, right? If we wanted to do 10 times to the third power, it would be 10 times 10 times 10. And you would rewrite 100, right? And then add this 0. And that would make it 1,000. Does that make sense? Okay. Let's talk about the different type of problems that you can see on the test when it comes to scientific notation. The first one you can see will deal with a positive exponent. In this number, 1,234 decimal 56. How would we say this? 56. How would we say that?
Just 0.56?
0.56. What's another way to say that? By its place value.
Place value?
Mm-hmm.
It'll be 5,600.
Perfect. The number 56 and the 6's in the hundreds place, 5,600. Now, remember what I told you. Where do we want this decimal to end up?
In the front.
In the front. So this decimal is going to end up where this 1 is, right? So the very first thing that you want to do is rewrite this number with the decimal after the 1. Now, every whole number that you see, you're going to write it the same way. It's just a decimal is moved. 2, 3, 4, 5, 6. Right? Then you put times 10, and then you count how many times that you move your decimal place to get to that 1. 1, 2, 3. Times 10 to the third power. Did you get that? Okay. Let's try tell me how I would write that in scientific notation.
In scientific notation,
Mm-hmm.
it'll be 9650.
Okay, 9, 6. Do I need to put anything after the 9?
0.95.
0.9? Now remember, this is what 0.9 looks like.
I mean, 9 point.
There you go.
Look,
it's the small things that make a big difference. 9.650.
0 times.
Would I have to put the 0?
Yes.
Technically, I wouldn't. The reason I wouldn't is, if you notice on this one, the only numbers I particularly care about are whole numbers, bigger than 0.
Oh, so the 0 doesn't matter.
No, I don't have to put the 0 on this one.
Okay, so it'll be just 9.65
Times.
10 to the second power.
Okay, let's see how many times that I move that decimal. 1, 2,
Third.
3. So it'll be 10 to the third power.
Okay.
Okay? And then let's do the reverse of it. Say I have this and I have to write the whole number. Okay? What I'm going to do is I'm going to put 9.65. And I know I'm going 10 to the third power. So because I'm reversing it, I'm going this way. I go 1, 2, 3. Put a decimal here and add a 0 there.
Okay.
And I end up with my original number.
Okay.
Does that make sense?
Mm-hmm.
Okay. Those are positive scientific notation questions. Let's look at negative scientific notation questions. Sometimes we have scientific notations that have a negative exponent. You would have a negative exponent only when you have a decimal before the number. If you notice in this one, the decimal came after the number. If you notice in that 900, the decimal came after the number, or that 9,000. In this one, the decimal is before the number. Okay? What I want to do is, I follow the same procedure. I still want to get the decimal in front of the first whole number, which is 6. In order to do that, I can go ahead and write 6.57, because those are my whole numbers, and I know my decimal is going to be right here, right? Then I'm going to put times 10 to the, how many times did I move to get to that 6?
3.
3. Here's the catch. Since the decimal came before the number, I got to write -3.
Oh.
You get that?
Mm-hmm.
So it goes 1, 2, 3. The decimal comes before the number, your exponent is going to be negative.
Always?
Always.
Okay.
Let's try 0.872. How would I write that in scientific notation?
It'll be it'll be 8.72 times
Okay.
times 10 to the negative first.
Okay. 10 to the negative first power. That's correct. Do we get that? Okay. Let's say we have the opposite way. Let's say we have the reverse of this problem. Let's say we have 2.56 times 10 to the negative third power. How do you think that I would write that? Because now I got to write a number. How do you think that I would write that number?
It'll be 0.00256.
Okay, let's see. First thing I want to do is I want to rewrite my number. And then I want to move my decimal point. Since I'm going to the -3, I'm going to the left. And I go 1, 2, 3. My decimal goes here. All my empty humps have zeros. So my answer would be 0.00256. Did we get that?
Yeah.
Okay. Scientific notation.